Hello, we are the Graphite Boys from the Kate Gleason College Engineering, and our project is Forge Graphite Collection. On our team, we have a project manager, Ben O'Cam, facilitator, Ben Issa, systems engineer, Zeb Blank, purchasing agent, Derek Basta, and communications officer, Giuseppe Morrow. We've been hard at work over the past 7 months creating a solution for our client, Pursuit Aerospace. Our client, Pursuit Aerospace, manufactures titanium leading edges for airfoils that are used in jet engines. The basic shape of the airfoil is achieved through a forging process which requires graphite lubrication to help the bar stock flow into the shape of the punch and die without getting stuck. However, graphite lubrication is extremely messy and has spread all over the facility and is a nuisance to the forge operators. The goal of this project is to design a system that collects and contains the excess graphite. We spent most of the first semester narrowing our scope to a project we can realistically complete. We decided to avoid changing the lubrication application process as we did not want to cause damage to the machine or parts by applying too much or too little graphite. We also want to minimize changes to the operator's step-by-step process to increase the chances of them adopting our solution. Lastly, while a facility-wide ventilation system would be most effective, it is far too expensive and complex for us, so we are focusing on just one forge process. We settled on a combination of a vacuum collection system mounted to an opening on both sides of the forge, as well as a front-mounted baffle to block graphite from hitting operators. Nothing is mounted to the back of the forge because there are too many thermocouples attached to the punch and die. We also included a baffle designed to redirect as much graphite as possible to keep it away from the operators. The system will be supported by adjustable feet to ensure stability during operation. We are currently manufacturing this system in the Brinkman lab to do a full installation in April with our client. After finalizing the CAD model, the sheet metal pieces were cut with a plasma cutter, then the pieces were tacked together with TIG welding, and the long seams were welded with MIG. We are currently on schedule to manufacture and deliver our solution to the customer before the end of the semester. We want to thank our guide, John Bonzo, our client contact, Jared Firth, our welding expert, Gary Hodenius, and all of the MSD staff, particularly Dr. Elizabeth DeBartolo and Christine Fisher. Thank you for watching our lightning talk.